Okey-doke. Now hopefully that sprint helped us wake up a little bit towards math. Maybe it didn't. Can you take your desk and see it? For some reason it got. No, Brandon, you're good. It's just kind of line up behind Brandon there. There you go. Okay. All right, so we are taking a turn today. We have been long divisioning it for a very long time now. And you guys have been doing such a fantastic job with long division. You really have. You've really, really grown with that. We're not forgetting it completely, but we are leaving it alone for a little bit to return to multiplication. We're returning to multiplication because we're going to start picking up a few other digits in the numbers, okay? Now, if that makes you nervous for some reason, don't let it, because I'm telling you, when you see how it's done, it's nothing to scare you off. It's just a little extra. It's just a little bit more, okay? We are going to also try it a few different ways with a few different strategies for a while. We'll take a few days to do that. Then we'll wind up landing on the standard algorithm that we'll stick with a little bit more, okay? But again, like we've done before, if you see a strategy or do it, if we work on a strategy and you like it better, then you can definitely grab onto that and use that once we start, stop learning about this stuff. Okay. So to get us warmed up with this, we are going to, no, haven't gone. They're trying to warm us up with stuff we haven't had yet. Actually, you might have had this in 3rd grade, but we're not going to talk about shapes yet and all that until we get into more of those units for us. So let's go here. Okay. These are just some warm-up problems. So I'm not asking you, remember we left off the place value chart with our division. But I do want you to try this problem on your board. Okay. Simply to get us warmed up and thinking this morning. This problem right here. So if you would put 348 divided by 6 on your board and go ahead and try to work that out. You can always check your work if you're sitting there finished. Can we get a 6 out of 3? No, so we're going to have to pull a digit from next door and look at how many 6s we can get out of 34. How many 6s what's the most 6s we can get out of 34?
5.
5, okay. Isabella, what is 6 times 5? 30, okay, so we're going to subtract that because if we went up to 6 right here, it would be 36, a little too big. So we're going to subtract that and get 4 and bring down the 8. And if you're like me, anytime I see a number that I know is a fact family, I'm like, oh, this is awesome. It's going to end easily. So how many 6s can we get out of 48? Yeah.
8.
Yeah, because 6 times 8 is 48. Okay. So 48 minus 48, because 6 times 8 is 48. And that gives us 0 with nothing else to bring down. So our answer is 58. We wanted to check it. 58 times 6. 6 times 8 is 48. 6 times 5 is 30, and 4 more is 348, which is here. Okay? Alright, no problem there. Let's jump to, is that, oh, it is multiplication. Okay, let's do one more. Just one more of the division. 2,816 divided by 8. Is that one I tried? Just had a few of these 8s problems on our sprint. How many 8s can we get out of 28? What's the most? Yeah.
2. Right now, I do 3.
Okay, what's 8 times 3?
24.
Okay. Because if I try to get one more, 8 times 4 is 30, what? 32, so that's too big. I'm going to subtract that and get 4 and bring the next digit down. How many 8s can I get out of 41? It's very close to one of our fact families. Yeah. Yeah, 8 times 5 is what?
40.
Okay. 8 times 5 is 40. When we subtract that, we'll have 1 and bring down the 6. And how many 8s can we get out of 16? This is a fact family. Yeah, 2. 8 times 2 is 16. So that leaves us with no remainder and no other digits to bring down. 352 is our answer, or so we think. If we check it, 8 times 2 is 16, 8 times 5 is 40, plus 1 more. Plus 3 is 24, 25, 26, 27, 28. There we go. Okay. All right.
Miss Wendy,
Mm-hmm.
for our multiplication, are we going to have 4-digit numbers? I mean, like...
Let's, in just a second, we'll get there and you'll see what we're doing today. All right, so let me go back to our regular slides here. Okay, so let's switch gears. Let's go into multiplication. So on your board, I want you to write this problem. Yeah, hold on. But go ahead and turn it. This one you can do eventually in mental math, but today let's turn it. Okay. 2,500 or 2,500 times 5.
Could do a few or sure.
I mean, standard algorithm is the fastest way, and that's the way I would do it. If you like partial product better, you can use it. What's 5 times 0, everybody?
0.
What's 5 times 0, everybody?
0.
What's 5 times 5?
25.
I'm going to put the 5,
Carry the 2.
carry the 2. 5 times 2? 10, 11, 12. So 12,500. Now, if you recognized that these are 25, if you recognize that, and if you know your money pretty well, and you know that 4 25s makes what? $1, which is 100 cents. So that would be 125 if I had one more quarter.
And you just add
Okay.
the 2 zeros.
And add the 2 zeros. So if you know your money well, and a lot of people that work with money a lot, maybe they're a cashier at a store or a restaurant, or they just work with money somehow, you might recognize that and can do that a little quicker with mental math. Okay. All right. On Friday, I gave you some questions with factors and multiples. We returned there just for a little bit, if y'all remember that sheet that we got for just a little bit. But it's good to have this every now and then, because some of us got it. A few of us struggled with the multiple question that I gave you. Okay, list the factors of 28. Let's do this like this. On your board, you can clear it off. Just put a 28, and then we're gonna scoot below it and do that thing with the arcs.
At the top.
Yeah, you can put it towards the top so that you have room underneath it. Okay. We're going to put the number 28, and then we're going to figure out the factor. So you can start that. You know that 1 and 28. Because even if a prime number, even a prime number is going to have those two factors. Okay, so let's go to 2. Let's go to the next number. Plus, I want to go to 2 because I know 28 is what kind of number? Even. So I know 2 is going to be a factor. So 2 times what?
2.
If I divided that by 2, what do you think? 14. Okay. So 2 times 14 makes 28. All right, let's go to the next digit. Let's go to 3.
Yeah.
Can we divide 28 by 3 evenly?
No.
I don't think so, but what's the closest we can get to 28? 27. And so it's just not, or 27. It's not going to work out evenly. So no 3s.
It's close.
Now no 4s. You should know 4 too. 4 times what is 28?
7.
Okay. So I know a 4. Here, those go together. Sorry about that. And the 7 go together. All right. So there's only 2 digits left between 4 and 7. There's 5. Is 5 going to work out? No. Because this number does not end with a
5 or 0.
5 or 0, so 5's out. What about 6? That's the only one left to check.
No.
You sure? 6 times what is closest to 28? 6 times 5 is 30. Back up 1. 6 times 4 is 24. Not close enough. Okay, so there are all of our factors of 28.
7.
1, 2, 4, 7, 14, and 28. Now, listen to me. On Friday, I gave you a sheet, and it said list the first 10 multiples of 4. And I had some of us really sit there for a long time and what does she mean? Okay, remember multiples can go on forever. So that's why I said I just want 10 of them. I just want the first 10. And by saying the first 10, I was also telling you where to start. Because I might say one day, hey, I want the multiples of 4, but I want you to start with 20 and do the next 10. On Friday, I just said list the first 10. So what's the first multiple of 4?
4.
4. And then you counted by 4s 10 times.
Yes.
Okay.
And it would have stopped at 40.
It did. I mean, there were that many blanks.
It's because 4 times 10. All you have to do.
Mm-hmm. But yeah, that's all it is. So here, if you get one like this and it says list the first 5, if it makes you feel better, put 5 blanks. Okay? Now it says the first 5, so I can start with 6 because 6 times 1.
6.
So 6 is my first one, and then I'm counting by 6s. So what would come next? 6 and then 12. Because that's 6 times 1. Well, that's 6 times 2. What's 6 times 3, everybody? 18. What's 6 times 4? 24. What's 6 times 5? 30. So even though I'm doing my multiplication table, my multiplication facts, I'm actually just skip counting. They're the same thing. Yeah.
Pretty much whatever, when it says list the first, like, any number right there,
Mhm.
and the multiples of the number, and all you have to do is pretty much multiply that number, and then get what you get, and then subtract by that number to what you get.
That's another way to get there. Okay. That's definitely another way to get there. So that's what's neat about math is there's more than one way to figure something out like that. Okay. All right. So this was all of our review and practice for today. You can go ahead and clear your board. Once you clear your board off, if you would put the top on your marker because now we're going to listen a little bit.
Oh.
Okay. All right. Now today, remember how when we start something, it does try to start you off a little simpler. And then we'll work into it. I don't know if you'd call it harder. It's just not as simple. Okay.
Oh, that's easy.
One of our numbers today is going to be a multiple of 10. So you're going to see that 0 today. And so today's method's just slightly different than how we'll do it down the road. Okay. We are using the area model today. Okay. We're kind of getting introduced to that. It will look a little different. The main way or the way we'll use it the most, it won't always have that 0, so it'll look a little different after today, but we'll at least get started with it. Okay, I don't want you to give me the answer yet, even though I'm glad. Okay, I want you to watch how we do it first, and then see if your answer matches. Okay. All right, so he's already figuring out an answer, and that's great. If you can do that, because this kind of goes along with that money thing we were talking about, so you might already know an answer. Great if you do. See how this method helps you also find the answer, okay? Because today is more about learning a method and how to do something more than just getting the answer, okay? So let's use this area model thing. The area model usually is always looking like a rectangle of some sort.
With little squares.
And this is why, okay? Because this is a multiple of 10, we're not going to split it apart. But usually with the area model, with a multi-digit number, we're going to pull it apart, almost like expanded form, okay? So I'm going to leave the 30 on the side for today. And the 25, let me change that color, hold on. I'm going to put across the top. Usually with area model, with multiplication, we're going to have one number on the side, one number across the top. Y'all know that from finding the area. Remember how we would multiply the length times the width, okay? We're going to take that 25, since there's 2 digits there that are not zeros, we're going to pull it apart into its place values. We're going to pull it apart into a 20 and a 5, okay? So we're going to cut it like that. We're going to say this is 20 and this is 5. Why are we doing that? The whole reason that you do that with area model and multiplication, just hold on, is so that when you're multiplying smaller numbers together that are a little simpler for us to multiply. That's all it's doing, guys, is it's breaking it down into smaller pieces, okay, so that then you'll take those smaller pieces and add them back together. Yeah.
On the teacher lessons when I read it, I'm doing this.
Good. So a lot of you have been, and so maybe this will help that make more sense. Okay. All right. Now, look at what we just created. Instead of 30 times 25 now, we've got 30 times 20, and we've got 30 times 5. 2 problems that are a little easier to attack and get an answer for than all of it together. Think about what we've done in the past when we've multiplied multiples of 10 together. Okay, we've got 30 times 20. This box is going to turn into 30 times 20 because I'm taking the length times the width, or the length times the width. Okay. What do you think the math problem will be in here?
30 times 5.
Exactly. 30 times 5. Okay. Because again, I'm taking the length of just right here and the width over here. Does that make sense? Okay. And hopefully you'll start seeing this the more problems we do like this. So now I just have to find the answer of these two things and add them together. Okay. So some people will actually even leave a plus sign right there so that they're thinking of it as, oh, I got to add that back together after I multiply it. What is 30 times 20? Jay, listen up, please. Okay. What is 30 times 20? Remember how we would do that? We would multiply the digits that weren't zeros, and then we would add the zeros. Miranda, what would it be?
60.
Not 60. Look at how many zeros there are. 3 times 2 is 6, but how many zeros are there? 1 here and 1 here. 2, so it's not 60, it's what? 600. Okay. Now 30 times 5, same thing. The 3 times the 5 plus 1 0, which would be what?
150.
150. 3 times 5 is 15 plus the 1 0. Okay. Now I've got 600, I've got 150, I just add those together. So a lot of people will come over to the side and add those up. 600, 150 is going to give me 750, and I bet that's what you had a long time ago in your mind.
I had the answer to that.
Okay. Now, Ishmael was light years ahead of me. I think he took 3 25s. If you had 3 quarters, that would be 75 cents.
That's what I was thinking.
And then just added the 0 to 75. Okay. Yeah.
Is it me or does it look easy?
It is. Area model is not hard at all. It's just I want to make sure you know what everything is about and what everything is for. But no, it's not hard.
It's not like the reason why I got it really quickly is because I said 25 times 0 and 25 times 3.
Okay.
It's not like
Okay.
long division when we did.
No, this is just, if you were to see this all worked out like this and nobody had explained it, it might first look complicated. If you really dig in and look at what we did, it's not difficult. It's just understanding where does everything go and how does it work. Okay? All right, so today, like I said a minute ago, all of our problems are going to have one of the numbers be a multiple of 10. So it is a little simpler. Tomorrow, when it's not that way, and this does not have a 0, we're just going to simply pull both numbers apart. Our area model, the rectangle I just drew, tomorrow or in the coming days, it may not be tomorrow, maybe 2 days from now, it's going to have 4 boxes instead of 2. But you'll see why. Okay? And we're going to see exactly what goes in each box, and then we add those 4 boxes up. Okay, so if you would on your board, at the very, very top, write 60 times 34. So that the problem is on your board. Okay. And go up to the top and write that so that you have plenty of room underneath it. And I do want you to go ahead and draw a rectangle, but guys, don't make it the size of your board. You need room to write on the sides of that rectangle. You also need room to write inside of the rectangle, so don't make it tiny. It's like 3 bears. It doesn't need to be too small. It doesn't need to be too large. It needs to be just right somewhere in the middle. And as we do this, you'll figure out, oh, this is too big or this is too small. You know. All right, we are going to cut it one time. We're going to cut it right about there. Most of the time it's not cut right in the center because we have a larger piece for the tens place, smaller piece for the ones place. All right. So now we're going to put our numbers in our math problems. 60 is going to stay on this side because we're not pulling it apart.
60 and 34.
Yeah. Okay, 34 is going to go on top because we're pulling it apart into those two pieces. We're going to put 30 because there's 3 tens. And we're going to put 4 right here because that's the ones place. Okay. So go ahead and make sure all of those numbers are on the sides and top of your area model. All right. So just making sure we know how to set this up. Now all you've done is create for yourself some smaller math problems to do. Okay. I do want you to write the math problem in the box. If I'm looking at okay, please look at this. If I'm looking at just this piece first, okay, what I highlighted in orange, I guess that's orange, kind of an orangey yellow. Anyway, if I'm looking at just that piece first, I've got 60 times what?
30.
30. So in here, I would write 60 times 30. Okay, because that's the area of that piece. Okay, what would I write in the other box? Ishmael, what?
4 times.
I can't hear you. What? 60 times what? This is 60. What is this?
4.
Yeah. So this is 60 times 4. That's the area of that piece. See, if like somebody was building a house and they needed the area of the whole house, but it was all these different, it wasn't just one plain rectangle, it was shaped funny, they could go to each room and find the area of each room and then add all of it together. It's kind of like we're finding the area of each room here and then putting it all together. All right, so 60 times 30. How do I do that? Well, remember a long time ago, 60. Wait a minute. No, never mind. That's not going to work. Not with this problem. All right, how do I figure out 60 times 30? What's my easiest way to do that? What's my easiest way to do that? Well, go ahead.
3 times 6 and then add 2 zeros.
3 times 6 is 18. Add the 2 zeros. Okay. All right. What about 60 times 4? Bailey, what would I do there? 6 times 4 is 24 plus what? Plus 1 0. All right, so I'm done, right? What's left? Okay, I have had people with this model, this strategy, forget to add up all the pieces. That's very, very important, or you won't have a total that's correct.
You're gonna count them wrong if you don't put the add on there.
Yeah, I mean, it's great if you can figure out the pieces, but I need to know that you know it's all of it together. So we've got 1,800 or 1,800, and we've got 240. Make sure you line them up correctly and just add them. And 2,040 is our answer. Okay. Now, this is what I'm saying. Either y'all have Monday face, you know, and I get it. I have a little bit of that myself. I'm trying to fight through it. Or this is really simple and y'all are bored to tears. You know.
Yeah,
Or it's a mixture of both.
Yeah.
Okay.
It's a mixture of both.
I think it is. even though this may feel super simple, like, remember what we said before, enjoy the simple days. Some days are not going to be simple, and so we can always go, oh, well, there's going to be a simple day again one day. Okay? Even if it's super simple to you, we still have to know how this process works. Okay? All right, clear off your board, and we're going to try one more together, and then I'm going to let us start doing more on our own. Okay? I am just simply making sure that you know how to set this up. I think you get the multiplication part of it. I want to make sure you know how to set it up on your board. Okay? All right, so our next problem looks like this. 90 times 34. So you'd write that on your board and then draw a rectangle. 90 times 34. We're going to cut that rectangle. Okay. We're going to put our numbers where they go. What's going to go over on the side over here?
90.
90, because it's a multiple of 10, and I'm not going to pull it apart. Okay? Miranda, what's going to go on the top? In this first section, what's going to go on the top? 30. Why? Because there's 3 10s right here. Okay? Isabella, what's going to go right here? It's going to be a 4. Because it's going to be the ones place right here. Okay? All right, so all we did was pull 34 apart, 34, and we have 90. Now let's write the math problems that go with each one. What math problems going in the first box? Yeah. This times this.
90 times.
Yeah, 90 times 30. Okay. Brandon, what would go in the next box? This times this.
90 times 4.
90 times 4. See, the thing with math, well, that's supposed to be a multiplication sign. The thing with math is that when I multiply, I can pull something apart and multiply all the parts and add them together. I'm still going to get the same number as if I left them as big numbers. Okay? All right. 90 times 30. What's the simple way to do 90 times 30? Yeah.
9 times 3 is 27, and then 2 zeros.
9 times 3 is 27. Add your 2 zeros. Okay. Knowing that rule or trick, if you want to call it that, makes this so much simpler. Martin, what about 90 times 4? What's my simple way?
4 times 9.
9 times the 4, which is?
160. 360.
Well, 9 times 4 is 36 plus 1 0. You're right there. 360. Okay, so we have our 2 pieces. What's left to do? Yeah. Not multiply. Even simpler than that. I've got my 2 pieces. I just need to, add them together. 2,700 plus 360. Okay. You have to be careful when you're going back and forth between adding and multiplying that we don't multiply here. 3,060. Okay. 3,060. Okay. All right. Go ahead and clear that off. We're going to try 1 or 2 on our own.
Are you going to make the problem up?
Yeah, because they're ready for the problem set, but I would feel better if we had 1 or 2 more.
I got one.
Okay, let's give that one a try right there. 70 times 47. Try your best to remember where things go. Like the math problems inside each box. Solve the multiplication in each box, and then you're going to add those two pieces together. So most of us have made it this far at least. Where some of us are getting stopped is the multiplication, making sure, because these are sevens. Making sure we got that. 70 times 40. 7 times 4 is what?
70 times 40.
28. Plus 2 zeros. Because there's 2 zeros here. 7 times 7 is?
48.
49. Plus 1 zero is 490. Now after all that, sometimes we accidentally add incorrectly. So be careful with your adding. Okay. 2,800 or 2,800 plus 490. Sometimes you know what it is? Sometimes we just don't line up our numbers right, you know? 3,290. Okay. As we move along and we learn different ways of doing multiplication with numbers this big or numbers, you know, that are like this, if you like this strategy the best, it's definitely something you can hold on to and use. Okay? Might not be the fastest one we ever do, but it's still, if it's getting you the right answer and it's the one you understand, there's nothing wrong with using it. All right, let's do one more, and then I think we're ready to fly a little bit. All right, so we're going to have 20 times 88. 20 would go here. Keep going if you're not 100% finished. Okay, that's how you're going to start off. Two times 8 is what?
16.
16, and then there are 2 zeros here, so 2 times 8 again is 16 plus 1 0. So you're adding 1,600 and 116. 1,760. All right, 1,760. All right, this doesn't feel too bad, does it? Okay.
I still like the vision.
Yeah. All right, I do want to explain about our problem. Yeah, go ahead and erase. I'm going to have somebody that goes over and does this. I'm going to try to get you not to. Okay, let's put our eyes up here for a second. When I got to looking at this lesson before today, the book has asked you to do some different things that I'm not asking you to do, okay? I was afraid if we did everything their way, that it's going to be more confusing in another couple of days because they're doing something a little different than how we're going to teach it in a couple of days. So this little thing over here where it's asking you about partial products, we're going to do partial products, but later, okay? So this thing right here, did it again, didn't I? This thing right here, I'm afraid even though it's not difficult, I'm afraid it's going to confuse you in another day or two. So please leave this alone. Okay?
Leave those two problems alone?
Leave this on this. It's the same problem. They just wanted you to do it here and here. Okay? Basically, what you're going to do is the problem, set it up just like we've just been doing, and then you're going to come over on the side and add the pieces up. That's all you're going to do. Okay? They just have the problem sitting there stacked up. And again, it's going to cause confusion in a few days that I don't want you to be confused about. Okay? So just, if you want to put an X on it, that's fine. But leave that space right there because you can come over here and add up your pieces. Okay? There are a few times where they don't have, maybe it's, yeah, let me show it to you. Nope. There. Okay. There are going to be a few times where they don't have the area model box. Just wait, guys. I do want you to draw it. We are doing the area model on all these problems, so there's a few times you're going to draw the rectangle. Sometimes they'll have it for you. Okay? All right. We are going to go ahead and take our restroom break, and we'll come back and take care of that. So go ahead and put your marker board up and your markers away.